a convex shape is a shape that is something like this, okay? Something like this, whatever. But in fact, it is any cluster that we will have will be some closed form, okay, that cannot where if you take any pair of points and you try to join them, the whole segment is inside the shape. You can't go from straight from a point to another, okay, by passing outside the shape. On the other hand, okay, if you see here on this diagram, this cluster limited by these two circles, هيدا الكلاستر البيج O هيدي البرانية اللي هون, okay. If you look at this cluster, it's not convex. It's if you go from this point here to this point here, you will pass outside the cluster. Same here for this question mark that is here. If you see, okay, this is a point. Clearly, this is a point in the cluster. This is another point in the cluster, and if you join them, you pass it through the outside. So, but sometimes we really don't have populations that result from a normal distribution or from anything. We really have clusters that are any shape, and this is usually when trying to detect. An example of that is when trying to detect shapes in an image. Okay, you try to detect, for example, a face in an image, like does Facebook, مثلا. You try to detect characters in an image in order to do OCR and then recognize what character is this, and then you try to have a text from an image. So this kind of situations, okay, which I gave images is just an example. Yani, detecting things in images is just an example, but in a large part of applications, we don't have convex clusters, okay? We have clusters that are connected by what we call a density region, and we need to detect these clusters. So in this case, we apply density-based clustering. So density-based clustering methods are able to mine non-convex clusters, where distance-based methods may have difficulty. In fact, distance-based methods usually detect only convex clusters, whether EM or k-means, or even agglomerative clustering based on distances. So an example of density-based clustering algorithms is, say, DBSCAN, which stands for density-based spatial clustering of applications with noise. So the ability of this algorithm to detect density regions and clusters, shapes that are dense and also regions that are just noise. And also لاحظوا with noise, يعني the algorithm will also reject this kind of points that are obviously just noise in an image or just noise in the data. Well, we will start here by studying DBSCAN. We have two algorithms to study in this chapter. The first one is called DBSCAN, فإذن يلي عم بحكي عنه, and another algorithm which is called DenClue, and we will see how they work and what kind of situations they might be useful for, and so on. Let us first start by defining a few concepts related to density. In fact, it all comes back to detecting something that is called the density at a point. And we have already studied this, if you remember, in the first few chapters when we talked about something like a histogram. You remember, we were trying to estimate the probability density function of something from our data, and we said, for example, let's take a point, okay, in the data. صحيح هونيك كنا عم نحكي بحكينا بس عن linear data, but we can still extend the concept. إذا باخد أنا مثلا a point like this, okay, and I say, well, what is the PDF, the density, okay, around this point? Basically, what I should do is take some neighborhood of the point, okay, and count how many items are inside this neighborhood. تماما مثل ما بعمل بالهيستوجرام لما يكون في عندي linear data، اوكي، باخد كل بوينت بقول مثلا العلامات اللي بين 80 وال 90 هيدي الدنسيتي للبوينت 85، اوكي، وهي مجموع العلامات، عدد العلامات يلي هن بين ال 80 وال 90. او اذا عم بحكي عن probability بقسم هالعدد على العدد الاجمالي للعلامات يلي هو كم تلميذ انا صلحت له المسابقه. ما هيك تتذكروا هالشي منيح يا محمد؟ شو شباب؟ طيب على كل حال عم سجل معي يا محمد؟
ايه دكتور انا معك.
ايه مذكر مزبوط اللي عم بحكيه، انه كيف شفناهم بالهيستوجرام وبالاستيميتنج ذا density. You remember that؟
ايه دكتور.
طيب فاذا هون نفس الشيء we will try to estimate the density, okay, to take a neighborhood of any point and to see the density of this region is defined as يعني the count or the how depends on how many points are exist in some neighborhood of this point in this region. بجوار هالبوينت كم نقطة عندي، يعني clearly مثلا هيدا محل ما حطيت أنا it's a dense region. On the other hand, if I take this point, it's an empty region. Here, it's a low density region. Okay, and so we need first to define, say, a neighborhood, and let's call it an epsilon neighborhood. Well, epsilon in the sense that the neighborhood shouldn't be very big, but at the same time, it's not really an epsilon بمعنى إنه ضروري تكون شغلة infinitesimally small. It's just a name, okay, here. A neighborhood or an epsilon neighborhood of a point X belonging to RD، لأنه احنا عم نحكي هون ب D dimensional space. صحيح عم نعمل دائما visualization in 2 dimensions, but what we're talking about is, say, a D dimensional space. So we define this neighborhood as, okay, a ball around the point. This is the point, and this is the neighborhood. It's a ball or a hyperbole around the point that I call B, D-dimensional ball around the point, centered at X, and with a radius of epsilon. Okay, I take a ball around centered at X and with radius epsilon, which is the set of points that have their distance to X, the set of points Y, such that their distance to X is less than or equal some epsilon, which is our radius. I define this as a epsilon neighborhood of the point X. Now, from this neighborhood, okay, we can estimate a density, basically, and see the more there are such points in this neighborhood, the more I say the region around the point X is dense. So we say that X is a core point. So first we define core points in the data are defined as those points such as the number of their neighbors in this neighborhood, the cardinality of this neighborhood is greater than a minimal number of points. فإذا دي بي سكان بيحتاج إنه بالبداية نحدد له انه انت قديش بدك تاخذ النيبرهود. How large you define your neighborhood, and also what is the minimum number of points that you need in order to define your points as core points. So if I go back to my initial diagram, this point, for example, is obviously a core point. Here's a core point. لأنه بالنيبرهود تبعهم اوكي عندنا عدد كافي من النقط، بينما هيدا مثلا هالنقطة هاي اوكي ما في شيء هون ضعيف، بس هالريجن هيدي هالنقطة هيدي is I define it's obviously okay not a core point because it is an empty region. So if I take any point in the in X and I define the neighborhood and I count the points and I have a parameter that I define as mean points, mean PTS, okay? This parameter, the minimum, if the count in this neighborhood, in this epsilon neighborhood exceeds mean points, I say I say that this point is a core point. It's a point in the data where the neighborhood exceeds some cardinality. Now we also define a border point. We will also define a border point, as in we defined a core point. We will also define a border point and a noise point. Now a border point is a point that is not a core point, but then it doesn't have enough in its neighborhood to be classified as a core point. Like here, say y, okay? In this example, I have taken, say, the cardinality of the core mean points, I have taken it for 5. So you see here x, in its neighborhood, I have how many? Counting itself, I should count the point itself. 1, 2, 3, 4, 5, 6. Well, x is a core point. Now, if I take the point y, and I also trace its ball, okay, I will find that y, okay, in its neighborhood has 1, 2, 3, 4, 5. Okay, if I had mean points equals 6, I will say that y is not a core point. But y is a border point. ليه؟ لأنه y is in the neighborhood of a core point. يعني x طلعت core point and y is in its epsilon neighborhood. y is not a core point but it is in the neighborhood of a core point. هي اللي بسميها شوفها إذن a border point. وهيدا يعني هيدا مثلا بنلاحظ انه هيدي النقط اللي على الاطراف هون اوكي هن بوردر بوينتس، لانه اذا بناخذها وحده لوحدها ما بتكون هي كور بوينت، بس بنلاحظ انه هي كمان هي obviously هي موجوده ضمن هالكلاستر هيدا هالشيب هيدا، ولو انها منا كور بوينت من جوا بس هي بوردر بوينت كانها على الادج تبع هالكلاستر هيدا. So we call it a border point. Finally, if I take Z here is a noise point. Why I say it's a noise point? Because it's not a core point and it's not a border point. يعني هي جاية معزولة، لا هي core point ما في شيء، ما في بالنيبرهود تبعها شيء كافي، وما حتى border point، يعني it's not in the neighborhood of X or any other core point لحتى نقول إنه هيدي تابعة لإله. فإذا بعتبر انه هيدي Z is a noise point. Usually by doing this first classification of our points, core, border, and noise, this is usually a first phase of DBScan, and already the good thing about it is that it already detects noise points and can already eliminate them from the image or from the data. Now, the algorithm which starts by doing this classification, okay? So the algorithm starts by computing the epsilon neighborhood of each point. For each point xi in the data set, it checks if it is a core point. It also sets the cluster to 0 for all points, indicating that they are not yet assigned to any cluster. فاذا شو بده يعمل الالجوريثم هلا دي بي سكان؟ بده يقول اوكي عندي هالداتا سيت يلي هي كل خلينا نقول هالداتا سيت هيدي يلي هي كلها النقاط، اوكي اكس اي يو سي اكس 1 اكس 2. بده يجي يقول اوكي كل وحده بدي اعطيه ايدنتيفاير لحتى يكون هو شو الكلاستر. This is فاذا كلاستر اي دي، وكله هيدا بعمل له انيشاليزيشن لشو؟ لزيرو. يعني كل البوينتس عندنا بعدهم assigned cluster 0. هلا each unassigned core point ببلش انه let's check the core points. كل core point ببلش is x1 a core point? Okay, I measure in its neighborhood and I count if there is enough points in its neighborhood. Well, x1 is a core point ما هيك؟ فاذا بقول انه شو I will assign it cluster ID 1. إذا هيدا cluster 1. طيب if it's not a core point, I move ahead. Now, I recursively find all its density connected points. يعني أنا جيت قلت x1 is a core point ورحت شفت x3 مثلا and I found it's in the neighborhood of x1. So immediately also and recursively I should check if also x3 is a core point. If so, okay, not only I will say that x3 is in cluster 1. يعني اوكي كل البوينتس يلي هن بالنيبرهود ل x1 يلي هن كلاستر يلي هن جيرانه ل x1 كلهم رح اقول انه هن هول بالكلاستر 1. بس x3 يلي هو كمان نيبر ل x1 اذا طلع عندي مثلا انه هو كمان كور بوينت، شو بعمل كمان؟ برجع كمان بجيب النيبرهود تبعه وبقول كلهم هول كمان صاروا شو؟ كلاستر 1. لحد ما خلص وشوف انه ما بقى فيني اضيف شيء على كلاستر 1. برجع بكفي وبشوف في x2 مثلا بعدها 0 بعدها ما انضمت لاي كلاستر، كمان بطبق نفس الشيء عليها. Is it a core? If not بكفي. لاقي point بعده I find each point each unassigned core point، يعني كل core point بعده ما تحدد الكلاستر تبعه. بشوف النيبرهود تبعه وكل بوينت بالنيبر تبعه بصيروا بكلاستر جديد برقم جديد، بصير كلاستر 2 او كلاستر 3 حسب الرقم اللي صرت واصل له. والجيرانه بصيروا بيكونوا بالكلاستر تبعه. وكل كل كمان كور بوينت بين جيرانه بيجي بطبق عليه نفس الشيء، بقول كمان انت جيب لي جيرانك. يعني بمعنى تاني انه هدفنا شو هون؟ هدفنا تنقول انطلقنا من هالنقطة اوكي وقلنا هيدي كور بوينت، فاذا بقول اوكي واضح هون هالجوار هيدا كله هو كلاستر 1. بس مش بس هيك، كمان هون بقول بعدني density connected، يعني في كور بوينت هو بالنيبرهود تبعي وهو كمان كور بوينت، انا بقول له كمان انت ضم جيرانك للموضوع. ثالث واحد it's also a core point in my neighborhood، بقول له give me also your neighbors وضمهم للكلاستر. بصير هيك النقط التابعه على هالكلاستر كلها تزيد لانه each time I add a core point I recursively and in the same way I add its neighbors to the cluster itself. طالما انه عم ننقل من كور بوينت لكور بوينت وديستنس بيناتهم اصغر من الابسلون يلي نحن عاملين له definition للنيبرهود، I pass from each point that is density reachable I say from an initial point it belongs to the same cluster. هلا بالاخر شيء بنلاقي انه البوردرز كمان انضموا للكلاستر، بس بما انه هن كور بوينت خلص ما طبقنا عليهم انه يجيبوا لنا كمان النيبرز تبعكم. يعني هيدا مثلا، هيدا البوينت اللي هون انضم للكلاستر بوقت من الاوقات لانه تابع لكور بوينت معين، بس النيبرز تبعوا له ما قلنا له جيب هول كمان لانك انت اصلا منك كور بوينت. خلص انت you are assigned to this cluster but you're not a core point, so I will not invite you to add your own neighbors again to this cluster. اوكي. واو. طيب شو يا محمد؟ well. طيب اوكي.